You hear a lot about entropy in talks of the heat death of the universe, the arrow of time, but what exactly is it? If you've taken an intro to physics class, you may have heard entropy described as the disorder in a system, which I always thought was a little too vague. But in more concrete terms, the most fundamental definition of entropy actually has to do with how many microstates correspond to a macrostate. I know those sound like big words, but let's break it down here. So picture a set of 3 light bulbs in a room. This is what we'll consider our system for this rough example. So our microstate here would be a description of exactly which light bulbs are turned on and off. So we'll label each one of them. Now, a macrostate we'll consider to be the total light that we are getting in the room, or the total number of light bulbs that are turned on more specifically. So for a macrostate where a total of 1 light bulb is turned on, there are 3 microstates we can have, right? Either light bulb 1 is on, or light bulb 2, or light bulb 3, with the others turned off. 3 microstates to 1 macrostate. Now, if we consider a macrostate where a total of 3 light bulbs are turned on now, there's only one way we can achieve this, right? It's the microstate where all 3 of those light bulbs are turned on. There are no other combinations. So the case with 1 total light bulb turned on would be a high entropy state. There are many combinations that'll give us this result. And the case with 3 light bulbs turned on would be a low entropy state. There's only one way to achieve this. Now, in a more realistic scenario, say for a cup of water, the macrostate description includes things like the temperature of the water, and the microstates are all the different ways in which the molecules are arranged and how they're moving. As you can imagine, this is a really, really big number. Hope that makes sense, and thanks for watching.